All right, this is Mr. Gilman. Today we're going to go ahead and continue to work on some word problems here, and we're going to use equations to help us solve these word problems. Now, some of these word problems can be solved in different ways without using equations, but that's what I really want to start working with is using simple equations to solve these word problems so that when we start getting to more sophisticated word problems, you have more than one approach than to just guess and check. So let's take a look here. And when you're solving the word problems, the first thing I want you to do is I want you to figure out what your variable is, define it. So if you don't know how much money is going to be the total, then put x equals, the total amount of money, or whatever it is. So I want you to assign a variable, all right? Usually it'll be, what is the question asking for? Okay, what's the question asking for? And today, if on one of the assignments, it'll be just, set up the equation. On another assignment, it'll say, set up the equation and find the answer. So what I want you to do is I want you to, if you find the answer, I want you to just think about it, and I want you to think about if it makes sense or not, because that's going to influence on whether or not you did have the right equation. Okay, you'll be able to tell. So let's take a look. And it says, Joe buys 9 CDs for the same price and also a cassette tape for $9.45. His total bill was $118.89. What is the cost of one CD? Okay, so the amount of money is what we're really looking for. The amount of money that one CD costs. Okay, so we'll say X, we'll say that X is the cost of one CD. All right, X is the cost of one CD. And so the more CDs that Joe buys, the more expensive it becomes. His cassette tape, though, never changes. It'll always be $9.45, and his total bill is always going to be $118.89, okay, in this specific problem. That's his total bill. So the total almost always is going to be on the right side of your equal sign. That's how much it's going to be at the end of the day, $118.89. And I know for sure that this $9.45 is not going to change because I only bought one cassette tape, and that's exactly how much it cost. So that's not going to change at all. We call that a constant. Okay, we know that word from when we were talking about expressions. There's no variable on it. But what does change is, or what we want to know, what our unknown is how much it costs for the CDs. So if you bought 9 CDs and we don't know how much it costs, but we also added that $9.45 to get to our total, then here's our equation. $9 CDs times however much they cost. So if they cost $1 each, it'd be $9. If they cost $2 each, it'd be $18, and so on. So our unknown is the cost of one CD, and the term 9x represents the amount of CDs, the cost of the CDs. 9 times whatever the cost was. But we also have that additional cassette tape cost, and our total we know is $118.89. So now I have this nice equation to solve, and I can figure out what the cost of one CD was. So now I'm just going to go through my steps of solving equations. This is a two-stepper, so I want to find something to add or subtract first, multiply and divide second. And so I'm going to say 44019 109.44, and then I'm going to divide both sides by 9. So I know that X, or the cost of one CD, in this case, equals 109.44 divided by 9. $12.16. So I know that $12.16 is the cost of one CD. So if I had 9 of them, I'd have 12.16 9 times, plus I'd also have my cassette order, and that would add up to 118.89. That does make sense, so I know that that's probably the correct answer in equation that I set up. If you need to pause the video to write down the long division, okay, we've been practicing this in the past, so I didn't want to hold us up on that, but that's how you long divide 109.44 by 9. So 12.16 is the cost of one CD. In this problem, it says Andrew buys 4 books for the same price and also a video for $18. His total bill was $110. What was the cost of a book? All right, so once again, his total bill is important, okay? We want to know our variable X or N or whatever you want to say is going to be the cost of a book. Okay, that's what we're trying to find. I know that the total bill ended up being $18 total. Okay, so however my costs all added up, all my costs added up equals $18. One of my costs oh, sorry. Excuse me. The total cost was $18. The total cost was $110. Total bill was $110. But I do know that I did have one specific purchase that was $18. And so that leaves me with however much 4 books cost. Now I could write however much, x, however much it costs for each book. Since it's the same, I can use the same variable, x plus x plus x plus x plus the 18 has to equal the 110. But I wouldn't write an equation like that with all those x's because I know they're all the same thing. So instead of writing, okay, x, I could say 4 x's. Okay, 4 books times whatever the cost was, plus my $18 for the video, should equal $110 total. So now this is an equation I'm going to set up. I'm going to see if I can figure out how much each book cost. Here's another good example of a long division problem. If you're not sure what 92 divided by 4 is, I'll show you again. How many times does 4 go into 9? Twice. 4 goes into 12 3 times. So I know x equals 23, or better yet, I would say that the cost of a book is $23. Let's see if that makes sense. If I had 23 plus 23 plus 23 plus 23 plus 18, would that equal 110? Yes, I think it would. I think this answer makes sense, so I'm going to say the cost of a book is $23. In this case, it says a shoebox with a pair of shoes in it weighs 3.9 kilograms. The box weighs 0.8 kilograms when it's empty. What's the weight of a single shoe? All right, so the total amount of weight inside the shoebox with the shoes, when it's all said and done, is 3.9 kilograms. Okay, I don't really need to label in my equation in this instance. I guess before we get started, I should say what is the weight of a single shoe. That's going to be my variable. X is weight of a single shoe. All right, X is the weight of a single shoe. And together, the box and the shoes together, the box plus the shoes together weighs 3.9 kilograms. But I do know that the box for sure weighs 0.8 kilograms without any shoes in it. Okay, we need to figure out how much one single shoe weighs. So I know that, honestly, this unknown for each shoe is going to be the same, assuming that both shoes weigh the same amount. But I wouldn't write x plus 0.8 equals 3.9. I would write 2x plus 8.8 equals 3.9. Okay, I have 2 shoes and I'm trying to figure out how much they weigh. Okay, add that with how much the box weighs, we know it equals 3.9. So in this case, as I go ahead and start solving my equation, 2x equals 3.1, and if I divide that by 2, x equals, and if you like another example of long division, we can do that as well. And I can bring down a 0 if I would like. So in this case, each shoe weighs 1.55 kilograms. One shoe weighs 1.5 kilograms. Okay, and I think that makes sense. 1.5 plus 1.5 plus the 0.8 should equal, 1.55 plus 1.55 plus the 0.8 should equal 3.9. That would make sense if each shoe really is the same exact size and weight. All right. Take a look at another one here. It says Anna has $300 to spend. She gets the game system for $85 and games cost $12 each. How many games can she buy? Now she wants to max out her budget here. Okay, we need to know X, how many games can she buy? So we could even say number of games. All right, so in this case, the total amount she has to spend, so usually the total goes on the other side of the equal sign, $300. She can't go over $300, but she wants to get as close as possible. We know for sure the game system, you only need one game system, is $85. That's the constant. It never changes. It's always just 85, and it's 85 one time. All right. Each game costs $12 each. So if we don't know how many games we can buy unless we figure this, we're going to find what we can add to the 85. That's going to equal 300. But each time I add a game, I'm not actually adding a game. I'm adding $12 times the game, because we're talking about money, finances. So every game I add, I'm adding another $12. So if I have one game, it's $12 more. If I had 2 games, it's $24 more, and so on and so on and so on. So the situation can be represented by 12g plus 85 equals 300. Let's go ahead and solve our equation here. 12g equals 215 and divide by 12. So in this case, the number of games she can buy ooh, so close. Let's see here. 12 goes into 95. Let's see here. 12 times 5 would be 60. 72, 84. Ooh. 7 times. So she can only do 17 games without breaking her budget, because after all, she wouldn't want to buy too many games. It'll be 17 and 9/12 of a game, but we can't buy 9/12 of a game. We would have to buy 18 games. Unfortunately, unfortunately, you can't. They're not going to round down for you at the store. You can't buy more than what you have to spend. So in this case, even though she can buy 17 and 9/12 of a game, really she can only buy 17 whole games and still stay inside of her budget. So she can buy 17 games.